Hello everyone! In the very previous video, What Algorithms, we discussed what is algorithm, classifications of algorithm effectiveness with mainly focus on a runtime. We started with accurate math model and then came to rough but important order of growth instrument, also named big O notation. Idea underneath big O is proportion between input data size and algorithm runtime. We provided common big O classifications, like for example logarithmic, linear, linearithmic, quadratic, etc. Important topic was about decomposing tasks into subtasks, reduction technique which allows to divide task into subtasks with applying the most effective known algorithm to each subtask. Often sorting is required as a subtask, so we introduced couple of implementation examples for insertion sort and quicksort and compared their effectiveness. If you haven't seen previous video parts, it's highly recommended to watch them before to proceed with this one, since we plan to refer to mentioned ideas. Let's start with discussing what the main reasons to study algorithms are. Why do we need to study? First of all, even though in the previous video we were mainly discussed algorithms in software developing, we need to admit that algorithms are surrounding us in lots of spheres in our lives, and we often can use analogical thinking. If you know how to effectively implement things in computer science, you can apply ideas in daily life routing. So algorithms can have impact on our lives. Isn't it a good reason to study algorithms? If you need to find element in preliminary sorted sequence of items, you can check every item from the very beginning till the very end of the sequence, which can take up to n steps, where n is the input data size. Such brute force solution corresponds to linear order of growth. Remember from previous video. But you can apply faster logarithmic order of growth approach instead, if you heard about binary search or half interval search algorithm. How? By comparing item you want to find with element in the middle of sequence. Since sequence is sorted, your element, if exists in a sequence, either in the middle found right away, either on the left or on the right side. On the first step, you already skipped half of the items from further searching, and you continue to apply same approach to left or right side. This is very fast logarithmic approach. If input data contains 1 million items, you need only 20 steps to find your item or check that it's absent. It's faster than brute force search, which can take up to million steps for the same task. I used the same logarithmic tactic when was trying to find sprinkler valve underground near my house for further replacement. Valve and its cover were hidden by grass after so many years. I didn't have special instrument like professional contractors have. Therefore, I was trying to find valve by a cable which should come from my sprinkler control in the left side of the house to valve somewhere to the right. I knew where a cable started being laid down underground. Once cable reaches a valve, it was a final cable destination. I expected not to have any cable after valve on the right. I could be able to use brute force algorithm and dig ground with shovel every 5-10 inches along with house wall, till reaching valve's cover. It would cost me up to 150 holes dug up. But I used binary search instead. I dug near the middle of the wall, detected cable underneath. Since cable should be going to the right by one dig, I skipped whole left part of wall's length. Next time I dug in the middle of the right half of the wall, found cable again. It took me a couple of more digs before I was able to find valve's cover. Only 4 steps instead of potentially 150. My laziness and knowledge of binary search saved me a lot of time during valve searching. We can find lots of other analogical examples. For example, how to find shortest path between two cities, if there are several alternative roads. In software developing, certain data structures, graphs, were introduced, which naturally help to solve such problems, and they are actually used in GPS navigators, along with accompanied effective algorithms. We will discuss algorithms based on graphs later in add-on video. So first reason is, algorithms are surrounding us in lots of spheres of our lives. Let's move to the second reason, why to learn algorithms. From the previous video, you may come to an outcome that brute force algorithms are intuitively easier to implement, since they by design check every input data item for solution finding. They give proper result in case of no obvious mistakes, but usually work not optimal, not effective way. When it comes to scientific grade algorithms with the goal to improve order of growth, intuitive easiness usually disappears. So you need to brainstorm to understand the design intent and conclude that algorithm is a correct algorithm. In other words, gives proper result for any input data. Remember how we discussed implementation of quicksort algorithm on the previous video, What Algorithms? For me personally, it took some time before I understood it. Intellectual stimulation and learning itself may be very interesting, is another reason to study algorithms. We will list most important types of algorithms and supporting data structures later in this video as a starting point for your further deeper dive into algorithms topic. Be ready to start journey in a couple of minutes. Third reason why to study algorithms is obvious. To be a professional programmer from one side, and to increase your chances to beat a job interview and land on interesting software developing job from another side. Programmers may be bad, average, or they may be good professional programmers. Linus Torvalds, creator of Linux, said, "Bad programmers worry about the code. Good programmers worry about the data structures and their relationships." Algorithms play a huge role when dealing with data structures and their relationships. We will see examples how algorithms are wrapping around specifically designed data structures later in this video. The next reason is applicable if you plan to be a scientist or to use scientific approach to learning subjects. The reason is to attempt simulating what might happen in nature to better understand and analyze natural phenomenon in controlled software development environment. For example, you can graphically mathematically simulate movements of molecules of different sizes in atmosphere, how they are colliding each other and as a result affecting each other trajectories, how they can travel in opened or closed environments or through different porous materials to analyze relevant processes like, for example, diffusion, which technically is spreading certain molecules in the air widely. Controlled software environment not only use laws of physics to simulate phenomenon, but also can help to imagine process by proportionally increasing sizes of molecules, so they can be visible on a computer screen. And it can help to decrease actual speed of molecules to the rate available to observe process on a screen by unaided eyes. Such visibility definitely helps to study natural phenomenon deeper. I would say it is avalanche-like process, similar to technological evolution discussed in our video Techniques and Technology, when several technological scientific discoveries helped to discover more and more new things based on previous ones. Similarly, nowadays, once computers and even supercomputers are becoming more available, people can develop more and more computational models of different natural phenomena. The more small parts can be simulated, the much bigger scenarios can be eventually simulated, like small pieces of larger mosaic. There might be extra add-ons to our examples with molecules discussed few moments back. For example, we can add larger molecules in our enlarged picture on a computer screen. And you can see how smaller, less heavy molecules around will impact big molecules movement. Again, all this is for a reason to better understand nature by simulating it. When you study algorithms, effective approach is to learn already discovered existing effective algorithms, like sorting algorithms, which were already discussed in the previous video, like key value search algorithms, graph structure-based algorithms, to be discussed in these and few add-ons videos. Such algorithms are most likely already implemented and embedded in most popular software languages. Then you may ask a question, why to learn them if they are already implemented? First of all, to know what algorithms to select among implemented, you at least need to know what algorithms exist. Not only list of most useful algorithms to know, but also how optimal they are in terms of performance and memory use for your particular task. Another reason to learn implemented algorithms is to understand basic ideas, implementation patterns, and data structures used, which may give you ideas for implementing new specific proprietary algorithms in production, not yet among available. It's like having wheels and gasoline diesel cars implemented, and you decide to invent new type of car, electric one. using same 4 wheels but different implementation. Another reason is, when you practice a lot, you also could see patterns of tasks, how to divide them into subtasks, and intuitively guess which algorithms are the most effective to use for solving some or maybe all subtasks. There might be more reasons to study algorithms, but overall it may be also for fun and profit. Like Mark Zuckerberg, who found effective similarities between people's social connections, and algorithms use graph data structures depicting such multiple connections between people, created Facebook social network and made quite decent money out of it. Similarly, you can find similarities between some processes in real life and software world. You can have fun and some extra income, maybe by organizing startup. Let's name few reasons why you need to study algorithms. To help ourselves in daily life, because algorithms can surround us in our lives. For intellectual stimulation and interest in studying algorithms themselves. To be a professional software developer. To prepare yourself for relevant software developing job interview. To simulate natural phenomenon for the sake of analyzing and better understanding in controlled software environment. To build your initial knowledge base of already implemented algorithms likely embedded in programming languages, and knowledge base of ideas for future algorithms not yet implemented. To practice and improve your intuition, which help to divide and apply proper algorithms among known. For profit and fun. The rest of this video and few add-on videos will be dedicated to show your starting point for your further knowledge gaining about algorithms. Before we proceed with algorithms, let's bring an abbreviation API into the table. It will be used later in this video and will be helpful for you in modern software developing world and in algorithms studying process. If you never wrote a code before, API stands for Application Program Interface. For simplicity, for now, we can determine API as an abstract announcement of functions procedures set. A real implementation is hidden when we talk about abstract API. Why it is important to use API? Because it allows to simplify process of learning and implementing. It allows to hide lots of steps inside implementation of specific procedure and announcing just description what to expect from this procedure, assumingly function implemented properly and works as expected. You can imagine for simplicity that your API is like a window in Postal Service Center, where some postman works and accepts postal envelopes and boxes for further sending. It's like a front line to talk to customer, with abstract procedures, like accepting different types of postage, regular, priority, express envelopes and boxes, measuring weight and size when needed, receive payments, or, in contrary, delivering arrived mailings. Actual real implementation of sending postage is hidden from customers. Once envelope or box is crossed a service window, implementation is hidden behind the wall and service center window. Postal service hides implementation. You should not think how postage is sorted inside, how it is properly routed to the end customer, how it is prioritized for sending via urgent avia transport or just slow ground ways on the tracks, how customs is cleared for international postage, and so on. But real service implementation, of course, is happening behind the walls. Another terms which are relevant to our discussion are front-end and back-end. These terms simplify concept used in lots of fields, where front-end refers to user interface or to communication with other systems, while back-end means actual actions behind the scenes, to receive requests and deliver processed information via front-end. So API, as functions set, is our front-end. When we write sentences in certain language, for example English language, we have rules of composing sentences. We need to include noun, subject, verbs, actions, adjectives with additional attributes to comprehensively express the idea between several people. Like sentence, we have rules of composing sentences, which I've just used. It has noun we, verb have, and adjectives, additional words. So you as a listener can understand what idea I want to share with you. Functions procedures in software developing usually also have certain syntax based on predetermined rules. Usually function has its name. Rule of thumb, it's good to have self-explanatory name. It can have input data parameters, usually syntactically included in brackets and separated by comma if there are more than one parameter. It can have output parameter, which function can calculate and return at the end of its execution. For our recent postal service example, we can have few functions like accept priority mail with input data envelope weight, paid price, signature confirmation. This is a function name. These are input parameters. This is a return value type. Function returns tracking number as an output string if envelope was accepted, or empty string if it was rejected due to incorrect price paid at the time of sending. Or another function, deliver postage box, with input data customer name, days at postal service, document is provided, signature confirmed, which returns true if postage delivered or customer picked it up himself, provided document and signed in case requested by sender, or returns false otherwise. From the previous video, you already learned how often sorting algorithms are used, as a standalone or as a subtask after decomposing the whole task. Remember reduction technique and some examples like convex hull. For example, you can implement procedure named isLess, which can compare two items of the same type. It might be numbers, characters, or other data types. Upon finishing procedure, we should have a result of a Boolean type, which can be either true or false, giving you an idea is first element is smaller than second. If you have function to compare two items, another function can be implemented sorting itself, based on isLess comparing elements functionality, for example quicksort algorithm. Do not pay attention to syntax. It's programmer language independent description just to share the idea with you. Some generated data structures are designed to implement certain algorithms, and such structures may have specific functions like adding item, removing item, shuffling, sorting, etc. Each function would have a list of step-by-step instructions implemented inside. But when we talk about API only, we talk not about implementation, but just about declaration, about announced list of procedures and their input-output parameters, if any. Such list allows to understand what high-level operations can be used when working with particular data structure and/or algorithm. From such list of functions, you should be able to understand what capabilities you are given, or you coded yourself if you did, what options you have to manipulate data structures, and how useful it will be for your algorithm. Our small API for quicksort algorithm can contain two procedures in its abstract API. Boolean isLess, item first, item second. Output set of items, quicksort, input set of items. You also can guess that sometimes one procedure from the list can be used by another. There is no need to reinvent the wheel and implement elements comparison inside quicksort function, since we already have one. In other words, isLess function can be invoked from inside of quicksort procedure. Please note that items to compare might be of complicated structures, so don't be confused and think why to implement such isLess function to compare elements. We are generalizing and not talking about simple numbers or characters only. You can guess another benefit of such design. Once list of functions are implemented, we have so-called modular reusable library. Wrapping up, abstract API gives an idea about design intent of operations by declaring a list of functions names along with input-output parameters. Actual implementation is out of scope of abstract API. That wall with service window we mentioned earlier for postal service can be used in general example, not limited to postal service, as a border between announced abstract API and hidden actual implementation. Just FYI, actual implementation is driven by algorithms, which provide methods for solving tasks. Before to return to our topic, I want to show a few data structures commonly used in software development and their APIs. First, two very basic data structures are stack and queue, which students usually learn at the beginning of data structure introduction. These structures allow to set the order of adding into and taking items out from a set. what are two main functions in a stack API. Stack has operations push to insert item at the end and pop to take and delete item from the stack's end. This is very helpful, having use cases when you need to implement actions which return back in reversed chronological order. That's how undo action is implemented in a word processor, or back button in a web browser handles, or recursive functions are implemented when they need to handle output parameters return within multiple recursive loops. The logic is very simple. Imagine you are working in word processor. You added first word in your document, remembers this operation in a stack as the oldest one. Then you add second word, remembers this operation in a stack as the next, newer item. Then you add third word, another operation saved in a stack. Then you make first word in bold letters. If you need to undo the last operation, it will be pointed by the very last element in the stack. So first word needs to return to non-bold letters case. Then you can add fourth word. If you need to undo operations, you continue undo them based on further elements from stack's end. Fourth word to remove, then third word, and so on. Exactly in reversed chronological order, based on stack's pop function. What are two main functions in another queue API? Queue has enqueue function to insert item in the beginning of a queue, and dequeue function to take out and delete item from the end of queue. This structure is very helpful when you make scheduling of processes, like tasks to run in a chronological order once they were received. Imagine you have limited resources, for example cashiers in a grocery store, where there are more customers than cashiers to pay for their purchases. Queuing works this way. First customer added to the queue, waiting line to the cashier. Then second customer comes to the same queue, then third, and so on. Cashier will start working with them in a chronological order. Whoever was added to the queue first will reach cashier first. The next customer comes second, and so on. Items, values, and types are out of scope of discussion about stack and queue structures. Mention functions care about the order, how items are added and removed, regardless their values. For example, heights of the customers coming to the waiting line are not important for cashier. But imagine strange situation that picky cashier in one store wants to take care of the tallest customer in line. And chronological order of adding customers is not important for him, but height is so important. Customers are coming. At certain point cashier is asking, who's next? And the tallest guy approaching the cashier. While cashier is working with the customer, another tall customer can be added to the waiting list. Next time cashier will ask for the tallest customer among accumulated, and so on. Operation for returning maximum number from a set is absent in Stacks API or Queue API. Another structure was introduced which takes care of values and quickly returns maximum, or in contrary minimum. This structure was named priority queue. We can separate max priority queue for returning maximum value from a queue when needed from min priority queue for returning minimum value. For maximum priority queue, API should contain following functions. Insert, to insert element into the priority queue. Max, to return element with the largest value without deleting. Del max, the most important function for this data structure, returns and removes the largest value. Additionally, we can have following functions. IsEmpty, to check is the priority queue empty. Size, which returns number of entries in a priority queue. So far we discussed several reasons why it may be beneficial to study algorithms. Mentioned what is API, which is a list of procedures declaration. And also mentioned APIs for stack, queue, and priority queue structures. In the second part of Why Algorithms video, we will discuss very effective way of implementing priority queue. See you there!